Yeah, good afternoon, every one of you. So until yesterday, we have seen this calculation of packed bed height. So Z is equal to NTU into HTU, and we have solved a couple of problems. So as I promised yesterday, so I will be solving the problem 2 once again. Okay, in a clumsy way. Just please try to grasp that problem. Okay, then finally we will see this one, absorption in rich gases, and if time permits, we will be seeing this absorption in with chemical reaction. So let us do the problem once again. The second problem. Problems are easy in this one, but at the same time somewhat lengthy problems. Just you have to look after that one. So this is problem 2. So a packet tower. So a packet tower is designed to recover 98% CO2 from a gas containing 10% CO2 and 90% air using water. Means CO2 is a solute and air is a carrier or inert and water is a solvent here. So a relationship y is equal to 14x can be used for equilibrium conditions. So no matter it is capital Y or small x, capital Y or small y, or capital X or small x, but you have to look after the definition of their x. Their meaning may be different. So you have to look after this one. So small y meaning kg CO2 per kg dry air, and small x means kg CO2 per kg water, means it is given in mass ratio. So mass ratio, and but these percentages are in molar mole fractions or molar ratios. We will be obtaining that one. Here the contrary is there. So we need to convert any one of them to the molar ratios, or this we have to convert into the mass ratios. So anything we have to do that one. Then the water to gas rate is kept 30% more than the minimum value. More than the minimum value. So L by G is 130 divided by 100. So calculate the height of the transfer unit if HTUOG. So height of the transfer unit is given as 1 meter. Then we have to calculate the height of the tower. Z we have to calculate. So solution for this one is, so first whenever you are seeing the problem, you have to draw this one. So there will be one inlet, gas inlet and gas outlet, and one liquid inlet and one liquid outlet. So what is gas flow rate? Here also what is gas flow rate? What is liquid flow rate? What is liquid flow rate? We have to define. And here what is mole fraction of solute in the gas inlet and mole fraction of solute. For example, this is 1 and this is 2. Then this will be Y2, mole fraction of solute in the gas outlet. Then similarly we have to define mole ratio of solute in the gas outlet. Then here also for the gas inlet, mole ratio of solute Y1. And here what is solute mass mole fraction in the gas outlet X2, this is what, and capital X2 is what. And here also X1 is what and capital X1 is what. We have to define that one. So the tower, packet tower is designed to recover 98% CO2 they have to recover. Okay, from the gas containing 10% CO2 and 90% air, means initially the gas G is having 10% CO2 and 90% air. So Y1 is mole fraction of your solute, that is CO2. So CO2 is 10%. This is 0.1 or 10 divided by 100. That is 0.1. So Y1, we can convert this since we already know 10% CO2 is there and this air is 90%. Remaining percentage is air. So molar ratio is nothing but moles of one component divided by moles of other component is called molar ratio. Then we can do this one, 10 divided by 90. So 1 by 9. So 0.111 you will get. Or otherwise this small y can be converted to capital Y. So Y1 is equal to small y1 divided by 1 minus small y1. That is 0.1 divided by 1 minus 0.1. So this also you will get 0.111. The next, so 90%, then relationship they have given is y is equal to 14x. So x they have defined as a weight ratio, kg of CO2 per kg of air. So this is y kg CO2 per kg dry air, Y meaning, is equal to 14 into X. So X meaning is kg CO2 per kg water is the X meaning on this one. So next relationship they have given is 30 percentage more than the minimum value. So what is this 30 percentage more than the minimum value? Okay, this data is given already. 98 percentage CO2 has to be recovered. So 98 percentage CO2 has to be recovered means, so that 98 percentage has to come into the liquid outlet. So this is liquid outlet. 98 percentage of this 10 percentage has to be separated out. Means 2 percentage it has to leave. To 10 percentage, 2 percentage of this 10 percentage CO2 has to be collected in the outlet of gas. So 100 minus, that is 100 minus 98 is equal to 2 percentage. Here gas will be 2 percentage. That is nearly 2 percentage means 10 divided by 100. So 2 percentage of 10 percentage. Y2 is equal to 2 percentage of 10 percentage. Why this 10 percentage means here only 10 percentage gas is there. But among the 10 percentage gas, 2 percentage has to come into the gas outlet. That's the meaning of that one. So 2 percentage means 2 by 100 into 10 percentage means 10 by 100 is equal to nearly 2 divided by 1000. 2 divided by 1000. Nearly you will get 0.002. So this is Y2 is equal to 0.002 small y2 and capital Y2 is equal to small y2 divided by 1 minus small y2. That is 0.002 divided by 1 minus 0.002. Nearly you will get the same thing. Yesterday we have solved this one. 0.002. So the data is okay. Here in the liquid phase, water is acting as a solvent. Means if you consider it as a pure water, so considering pure water, we can designate this mole fraction, mole fraction of your solute in the solvent is 0. Then this capital X2 is also 0. But here we don't know 98 percentage of this 10 percentage coming, that we have to calculate using the necessary conditions. So after converting this one, let us convert this also. So here it is molar ratios. In terms of molar ratios, all the values are there. But here is the mass ratios are there. So to convert into the molar ratios, we have to divide this kg. We know that moles is equal to weight by molecular weight. That is weight is in kg. So molecular weight is in kg per kg mole. Then kg cancel. This kilomole will be going to the top side. So same thing we have to apply here. That is kg CO2 per kg dry air. In order to convert this kg CO2 to the molar ratio, we have to divide this CO2 with molecular weight of CO2. That is molecular weight of CO2 is 44. That is kg per kg mole. So this kg and this kg will be cancelled and it will be extremely numerator it will be going. Then divided by this kg dry air, we have to convert once again into the moles. So 1 divided by 29 kg per kg mole. Then this kg and this kg will be cancelled out. This will be going to the extreme numerator. Then kilomole per kilomole will be the molar ratios will be the units for that particular case. For that particular case, that will be the kilomoles. Then is equal to 14, and this also has to be converted to capital X. So here also same thing, kg CO2 per kg water. So to convert this kg CO2, we have to divide with 44. That is CO2 molecular weight. Then kg cancel, kilomole will be obtained. Then once again to convert this kg water to kilomole, we have to divide with 18. So finally we will be getting Y. So this 44 and this 44 we can cancel out, and left out is this one. This 29 will be going to the extreme numerator. That is Y29 is equal to 14 into 18. Though this 18 also will go to the top. 18 X, capital X, that is. So Y is equal to 14 into 18 divided by 29X. So this one yesterday we have obtained around I think 8.734. 734 capital X. Yesterday we have done this one. So after calculating this numerical value. Okay, then we have converted into the mole ratios also. This one also mole ratios we have converted. Then So what about the remaining data they have given? So the water to gas rate is kept 30% more than the minimum value. So calculate the height of the tower. So what we have to calculate? Height of the tower we have to calculate. Z is equal to what? And HTU they have given 1 meter. So we already know Z is equal to HTU into NTU. So here this is known. This is unknown. This is unknown. So one thing is known, two variables don't know. We have a formula for this NTU. But then easily you can product out this NTU and HTU. You can find out the Z value. So to do that one more clue they have given is water to gas rate. Means water is a liquid, gas is a G. So L by G rate is, so L by G on actual conditions. Actual conditions is maintained 30% more than the minimum value. Means 100 plus 30 divided by 100 into L by G minimum. So apart from the minimum value, 30% more than the minimum value has been maintained. Means so this is L by G actual is equal to 130 divided by 100 into L by G minimum. L by G minimum. Therefore, we can write L by G actual is equal to 1.3 L by G minimum. So this is the clue they have given. Now we have to calculate whatever the required parameters there. We have to calculate that one. So how to calculate that required parameters? Using the mass balance, using the mass balance or the component balance of the equation for the solute here. So what is the mass balance here? For example, let us consider only capital Y's. So this is, if bottom is considered as 1 and top variable is considered as 2. So this will be G into Y1. This will be liquid outlet, means G into X1, L into X1, and this will be liquid inlet, that is L into X2, and this is gas outlet, that is G into Y2. So we know that general mass balance equation without chemical reaction, and where steady state is sum of the inputs is equal to sum of the outputs. So input is, one input is G into Y1 plus another input is L into X2 for the solute is equal to one output is G into Y2 plus another output is L into X1. Therefore, all the G variables we can separate on one side, G into Y1. So this will be coming to this side, that is minus Y2. So L into X1 minus, so this will be going to this side, that is X2. Therefore, we already know X2 we are considering as a pure solvent. Okay, X2 is equal to 0. So this we can put it 0. So therefore, G into Y1 minus Y2 is equal to L into X1. So therefore, L by G. So here the clue they have given is L by G actually is 1.3 times of L by G minimum. So this formula we have to write in the form of L by G. So L by G is equal to Y1 minus Y2 divided by X1. So this we have obtained. Now that condition is, one is at minimum condition, minimum L by G. The another condition is at actual L by G. At actual L by G, at minimum L by G, we have to evaluate our parameters. So how to evaluate our parameters at actual conditions, at minimum conditions is, at minimum conditions first we have to evaluate. So when we are evaluating at minimum condition, first thing we have to consider is this equation, balance slope equation. That is y is equal to something, yeah, this one, 8.734 x. First let us consider that one. So y is equal to 8.734 into x. We have this clue. Using this clue, we can write that y1 is equal to 8.734 x1. So we know already what is y1, we already know. X1 we don't know. So then we can write x1 is equal to y1 divided by 8.734. That is y1 is 0.111, I guess. Yeah, y1 is 0.111. That at minimum conditions we can evaluate 0.111 divided by 8.734. Therefore, this x1 we have obtained yesterday is 0.0127 we have obtained. Okay, please verify with your values. Yesterday we have calculated these values. So x1 is equal to point, this one we obtained. Now at minimum conditions, we know that L by G minimum from this formula. Okay, from this formula, we know that L by G is equal to, at minimum conditions, y1 minus y2 divided by x1. So all the variables now we have. So let us calculate what is L by G minimum first. Is equal to y1 is 0.111 minus 1, y2 is 0.002. That is 0.002 divided by x1. Just now we calculated, that is 0.0127. So this we got yesterday. L by G minimum is equal to something 8.582 or something we got. So this is L by G minimum. Now already the minimum value we already know. Now in the actual conditions, at the actual condition, we know that L by G actual is equal to 1.3 times of L by G minimum. Now let us calculate what is L by G actual. That is equal to 1.3 into whatever the value now obtained, that is 8.582. That is L by G minimum. 582. That is L by G actual is equal to 1.3 into 8.582. So that is around 11.156. Yeah, I think 156 we got. So this is 11.156 we got the value. Now we already have a L by G actual and L by G minimum. From L by G minimum we have calculated L by G actual. So let us use the same formula once again and determine the true x1 value at actual condition. X1 value at actual condition. That is L by G actual is equal to y1 minus y2 by x1. So L by G actual we already know, that is 11.156 is equal to y1 we already know 0.111, y2 also known 0.002 divided by x1. So now x1 actual x1 we have to find out, that is 0.111 minus 0.002 divided by 11.176. So nearly x1 we got 0.0098 we got this one yesterday. So now all the values are there. All the four material balance values around here in this figure, everything is there. Okay, now everything is there in this figure. Okay, all the values are there. Now we can directly use our NTU equation. So in the NTU equation, we already know what are the required parameters. Okay, YE1 is still we have to calculate. So let us write NTU equation first. So we know that Z is equal to HTU into NTU. So NTU is equal to Y1 minus Y2 divided by Y minus YE ln. So that is Y1 minus Y2 divided by Y minus YE ln means Y1 minus YE1 minus Y2 minus YE2 divided by ln of Y1 minus YE1 divided by Y2 minus YE2. So now we have Y1, Y2 we have, but we don't have YE1 and YE2. So let us consider this equation. Y is equal to 8. This formula 8.734x. 8.734x. That is, from this formula we can say that YE1 is equal to 8.734x1. So this x1 is at actual value, not from the L by G minimum value. So then we have to calculate YE2 is equal to 8.734 into x2. So x2 we already know it is 0. So therefore YE2 is equal to 0. YE1 is equal to 8.734. X1 is just now we calculated 0.0098. 0.0098. So therefore this is YE1 is equal to something we got 0.0856. Yesterday we got this value. Then let us use all the values, summarize all the values here. Y1 is equal to 0.111. Y2 is equal to 0.002. Then YE1 is equal to 0.0856. YE2 is equal to 0. It's a 0. So now we can use NTU equation, that is Y1 minus Y2 divided by Y1 minus YE1 minus Y2 minus YE2 divided by ln Y1 minus YE1 divided by Y2 minus YE2. So now substitute all this in this one. So that is Y1 is 0.111, Y2 is 0.002 divided by Y1 is 0.111, YE1 is 0.0856 minus Y2 is 0.002 minus YE2 is 0 divided by the same thing, that is Y1 is 0.111 minus YE1 is 0.0856, then Y2 is 0.002 minus YE2 is 0. Then after calculating this one, we have obtained yesterday 11.84 nearly. We got this one NTU. We know that HTU is nothing but 1 meter they have given. So this is given data. Then we know that Z is equal to HTU into NTU. Therefore, HTU is 1 meter and NTU is 11.84 without units. So then it is called Z is equal to 11.84 meters. Okay, this we have solved this everything yesterday. Just for the summary, I am just discussing once again. Okay, I hope this problem is clear, everybody.
Yes, sir.
Yeah. So